Hello, everyone, and welcome to the first summit from AutoML and Training Working Group in Kubeflow. Thank you so much for joining this time. Again, if you just want to ask any questions during the summit, you can use the Zoom chat. And in the meantime, I will just post again in the Zoom our link to our schedule. So you can just take a look what is the schedule will be today. And I think we will start with the first presentation, which Zhou will present. If you have any questions after the presentation, please feel free to do it. T, you can start with sharing your screen.
Okay, thank you, Andrew. So, can you see my screen?
Yep.
Okay, great. Okay, so hi everyone. This is Zhou from Baidu, and I'll make the paddle operator and elastic deep learning presentation today. For those people who are not familiar with paddle, let me give out a brief introduction of paddle deep learning framework. In 2012, Baidu already started using DNN models and the deep learning technologies adopted in audio recognition, OCR, and etc. And in 2013, an Institute of Deep Learning get established, and the deep learning platform Paddle is designed. And later, Paddle supports the large-scale distributed training in 2014, and deep learning model being applied in search engine business for the first time. And in the 2015, Baidu published the very first online the neural machine translation system. And later, Baidu open sourced the Paddle in 2016. And in 2018, we have the 1.0 release, and in 2020, we had the 2.0 release. Okay. And currently, Baidu is China's first fully open source deep learning platform, and it is also an agile framework for industrial development for deep neural network. Paddle deep learning framework supports both declarative programming and imperative programming. And Paddle also supports the ultra large scale training of deep neural network inside Baidu. Paddle supports the training of deep neural network with 1 billion of features and trillions of parameters using data distributed over hundreds of nodes. And the Paddle including and maintains more than 100 mainstream models that have been polished over a long time in the industry. Some of these models have won major prizes from well-known international competitions. In the meanwhile, Paddle has more than 200 pre-trained models to facilitate the rapid development of the industrial application. We can see in the graph that Paddle projects are organized by 4 parts: the core framework, the basic model bank, the end-to-end development kit, and the develop tools. Okay, we can see on the pics that currently Paddles support more than 270 official models covering NLP, CV, speech, and recommendation. We have 4 base model zoos, including Paddle CV, Paddle NLP, Paddle speech, Paddle rec. And for each model zoo, we have several task level specified fields. Like the Paddle CV, we have image classification, the object detection, segmentation, etc. And for each task, we developed all related algorithm operators. Most of the operators are used in the industries, and some of them are the winners of the worldwide competitions. And let's see how Paddle distributed training progress right now. When Paddle project was launched, we took distributed training as the basic ability. In this field, Paddle have many pioneering technologies. In 2018, the first generation of Paddle consists of pure CPU machines, and the parameter server model could support model training with trillions of sparse parameters. And later, as network structure in the model become more complexible, and as well as the further pursuit of training efficient and cost performance, the parameter server technology was also updated. And the second generation is the pure GPU parameter server, which integrated with the 3-layer storage architecture and the RPC and NCCL hybrid communication with multiple highlight technologies. The model training supports previously it's used 100 CPU machines, now can be completed replaced by one multi-core GPU machine. And recently, Paddle Framework 2.0 was launched, and the third generation parameter server technology, which is called the heterogeneous parameter server. We can use like different kind of GPU card, like the K40 and the V100 in the same network, and it will like save lots of like resources in our cloud and perform the same as usual. And we did a lot on those kind of job, and we just want to the utilization of the cluster as maximum as possible. And later, in order to train the large scale model efficiently, Paddle has innovatively launched the industry's first 4D hybrid parameter strategy based on the collective communication technology. That is the data parallel, the model type parallel, and the pipeline parallel, and the group parameter slicing. Those 4 strategies are used in combination. Through the 4D, which we call the 4D hybrid parallel strategy, users can completely training the task for dense parameter models with a scale of hundreds of billions parameters. After testing using the 4D hybrid parallel strategy to train 230 billion parameter ERNIE model, this ERNIE model is Baidu's largest NLP model, and the training speed reaches around 8,700 tokens per second, which is like 24% faster than the original 3D hybrid parameter strategy. At present, most of Baidu's intelligent services are powered by the Paddle framework to provide the training and the inference support, such as Baidu App, Tieba, Baidu Map, and Baidu Translation, etc. Okay, we've talked a lot about Paddle. So let's see how cloud-native training gets evolved in Baidu. In terms of the cloud-native AI system, in 2011, we started using Baidu's self-developed container technology, which is called the Matrix, to containerize the training job. And then we used the Slurm framework to support distributed training. And then Baidu developed the online and offline hybrid scheduling system, which called the Normandy, to maximize the cluster utilization. And then with Kubernetes coming to our eyes, we use device plugin to support native hardware support, such as in NVIDIA GPU. And later, we implemented a training task operator based on Kubernetes to support native distributed training. And recently, we did a lot optimization in resource utilization, like the job force tolerant, the task auto-scaling, and the knowledge distillation. We will talk about all kinds of technologies later. Currently, we created the Paddle operator and the EDL project as the middle layer between the Kubernetes and the Paddle framework to handle the elastic training related stuff. EDL itself is an RFAI Foundation incubating project designed to help deep learning cloud services to providers to build the cluster cloud service using deep learning frameworks such as Paddle. The project was originally developed and open sourced by Baidu, and it is licensed under the Apache 2.0. Currently, EDL uses the Kubernetes as the foundation and provides user scenarios, including the predictive training methods such as the knowledge distillation, reinforced learning, and the hyperparameter search. And now with 3 major releases, paddle operator, and EDL enable the snapshot-based fault tolerance, the job autoscale, and the knowledge distillation natively. And EDL also highly integrated with Volcano for advanced scheduling features to accelerate the training speed. And recently, we start getting involved into the Zhou project for our caching system. We will talk about them later. With all kinds of technologies inside Baidu, the cluster level resource utilization is above 70 right now, which is a huge progress. Okay, so let's talk about the fault tolerant. When Paddle do the large-scale distributed training, like thousands of GPU cards for single NLP training job inside Baidu, we suffered from some problem. The first problem is when one of the pods in the large distributed training job got failed, the whole job failed. As the scale of the training node increases, the probability of job failure caused by machine failure also increased. And the job failure requires a reallocation of computing resource to restart the training, resulting in low GPU computing resource utilization or even waste of those resources. Another one is the low utilization of some inference card cluster, like a K40 cluster, while the training card cluster like V100 cluster is always out of resource. So we need to figure out a way to resolve those two main problems when training the Kubernetes cluster. In release 0.2, we propose the fault tolerant capacity. Training tasks can be shut down at any time, and subsequent recovery will be based on the first snapshot. At the same time, on the user side, we provide a non-intrusive API to make user unaware of the fault tolerance. And the picture above is an example of how our distributed training works. The user does not perceive the fault tolerance of distributed training. You can see that data can still be synchronized even the trainer has. Hello? Okay. You can see that the data can still be synchronized even trainer hands up due to the error and then restart the whole job. Okay, in release 0.3, we proposed the service-based knowledge distillation. Compared with the traditional distillation training, EDL service distillation training decouples the teacher model and the student model in different network. The teacher model is deployed as an online inference service, and the student model use the client to send a sample to the teacher model in real time to obtain the inference result from training. There are several benefits for that. The first is it will save the GPU memory resource. Due to the decoupling of the student model and the teacher model, the service distillation training can use the heterogeneous resources, that is, deploy the student model and the teacher model to different devices. And the second is to improve the utilization of training resource. In real application, we can deploy the training teacher model to an online elastic inference card cluster like K40 and use the computing resource of the online predictor card to increase the throughput of the student model in the distillation training task. When offline training resources such as V100 are limited, the online card is used to accelerate the training to save valuable training resources. And the upper picture is the flowchart of the service distillation training operation. In this figure, you can see that the student model sends samples to the teacher model and obtain the inference result, while the service side, while the teacher model can be added and deleted at will and adjusted flexibly. Okay, in order to verify the effect of the service distillation training, we use the traditional like distillation training, the same network distillation training, and our service distillation training on the ImageNet dataset to train the ResNet VUD model. And for the accuracy part, compared to the traditional one, the service distillation training improves the accuracy of the ResNet VD by nearly 2%. And in terms of the training speed, compared with the traditional one, same network distillation training takes up a large part of the computing power due to the teacher model. So the training speed is only 36% of the traditional one with the same training resource. The service distillation training, which we proposed, used the additional online P4 elastic resource and transfer the teacher resources requirement for the training card to the elastic card. So compared to the original one, it still maintains a training efficiency of 83%, and the speed is 2.3 times to the same network distillation training. Okay, so recently we start integrate with the Volcano. In terms of the scheduling system, right now we highly integrated with Volcano on the GAN scheduling and the queuing. We natively support Volcano in pad operator and make users aware of leveraging the Volcano. So on this page, you can see that in the containers arc, you can directly specify the scheduling with Volcano. And on the configuration side, when you configure paddle job YAML, you can see that you can directly specify the scheduler name as Volcano, and we will make all the other stuff for you. We will generate the pod group. We will put all the pods into the same pod group, and then start up the pod group and the pod. So currently we support the GAN scheduling and the priority queue for Volcano, and later on we will support more features with Volcano, and we will cooperate with the Volcano community a lot on the advanced technologies. Okay, and for integrating with the JuiceFS, here we are talking about the cache system right now in pad operator. Currently, the separation of the computing and the storage architecture leads to the high latency of data access and the slow training in our inner cluster. The deep learning tasks used by the model team they need to access a large number of small files, and the performance difference between reading the massive small files from remote storage service and reading from local is nearly 10 times or even 100 times. And the second one is the Kubernetes scheduler have no perception of the data cache. And the same data source run multi times and access is still low. The same models, different hyperparameters, the fine tuned models, and all those kinds of like data related stuff. They repeatedly access the same data, which can be reused by the data cache. However, because the native Kubernetes scheduler cannot perceive the cache, the results of the application scheduling are poor. So the cache cannot be reused, and the performance cannot be improved. And the third part is the Paddle framework itself does not provide interface for storage services like the HDFS or BOS, which may lead to the need of support for both POSIX interface in the model development stage, or have the HDFS or BOS interface in the model training stage, which introduce the complexity of adapting the model code to different storage system. So we introduced the JuiceFS, which is a newly developed the cloud native caching system into our project. When the local machine does not have cache data, JuiceFS can put training samples about 2 to 3 times faster than the traditional like BOSFS, or like the JuiceFS has better performance than BOSFS in the small file IO scenarios. And we added a sample cache component to the pad operator, make full use of the memory and local disks in the cluster to cache sample data, and schedule paddle jobs to train on the node with sample cache. We can greatly access the sample reading speed, thereby shorten the time of the entire training task in this scenario. Okay, we've talked a lot about the technologies we've used in the paddle operator. So so in this page we will also talk about the community cooperation. In terms of the open source community cooperation, we've already working with lots of the upstream and ecosystem projects for building up a good deep learning open source systems, including like for the training side, we've already cooperated with the Kubeflow, Volcano, MLflow, those projects. And then for the serving side, we've cooperate a lot with DJL, Bento ML, AD-Link. And then for the model side, we've also cooperate a lot with Milvus, Onyx, those projects. And we hope that with all those open source ecosystem get established, all kinds of developers can easily select all the tools they need, and they can build up the system much faster than before. And this is all what we want for the deep learning ecosystem, open source ecosystem at this moment. Okay, here are all the links for the paddle operator and the paddle and even the EDL. So currently we put the paddle operator in the Paddleflow organization, but later on I think it's already in the final process. We will put it into the Kubeflow organization. And we host our paddle project, paddle framework under the paddle organization. And also, we host our EDL under the LFAI Foundation, which is located in the Elastic Deep Learning organization at this moment. And for the EDL, you can go to our homepage, the elasticdeeplearning.ai, for more details. Thanks. And if you have any questions, please contact me directly, and we can have further discussion about how to build up a elastic and fault tolerant deep learning system. And we can for not only the paddle operator or the EDL, we just want to have some common way for most of the developers to build up a ML ops or DL ops system, which can facilitate all the developers with all kinds of frameworks. That's it. Thank you.
Thank you for the great presentation, T. It was really exciting. Do we have any questions from the community to ask T?
So one thing would be like, it would be interesting if you can share the roadmap planned for the Kubeflow training operator. What you're planning for the upcoming release, or probably like in next 1 year.
Okay, so because we are the paddle operator, so we mainly focusing on the how to make the paddle training stuff to be more cloud native and to cooperate with the whole ecosystem. But additional with that, we are trying to make some common stuff. Like for EDL, it's not the paddle specified stuff. It's the it will be abstract, and it will support all kinds of frameworks, deep learning frameworks later on. And we think, and in Baidu right now, we are working on like the fault tolerance for our NLP job, which is like for one single job, it will cost thousands of GPU cards. So we want to make those kind of experience to get out and to have them into our external to make it into our external project like EDL. And so for people who don't have such kind of experience of how to handle really large like a GPU card training stuff, they can just go to our project and see what we are doing, and then maybe they can just use the project, or they can migrate all kinds of code to different kind of frameworks so that all kinds of other frameworks can get those kind of capacities, capabilities, like the fault tolerance, the distillation chaining, even later on with the auto scale stuff for their deep learning like frameworks later on. Is that answer your question?
Thank you.
Yeah, that sounds very interesting. By the way, like another question about like integration with Kubeflow. So I was able to find that you supporting like GAN scheduling that you discussed. Will pedal operator and Kubeflow support this kind of schedule processing? Because this is, I think, very interesting from the distributed training perspective.
Let me repeat the question that you say that right now we are supporting GAN scheduling. Yep. Would that be directly using?
Yeah, the question is like, will pedal operator support it?
Yeah. So currently we are using using Volcano to support that. So Volcano has all kinds of capabilities right now for the GAN scheduling or like a priority queue, and we don't think we will reinvent those kind of stuff because Volcano is right now is quite mature, and we are happy to using that. But later on, we think we can also cooperate with the scheduling ecosystem for advanced recently we've seen. Yeah, recently we've seen lots of new technologies. For example, in these days, like the OSDI conference, they have some kind of advanced scheduling technologies. Like the best paper for the OSDI 21, they have some kind of new scheduling policies, which will highly increase the utilization of the resource, the GPU resource. So we are quite interested in that. We will take investigation into that, and then we'll see that whether it can be integrated with Volcano or it can be invented as another project. That's totally fine to us.
Yeah, thank you so much. Do we have any other questions from the community to ask T about pedal operator? Going once? Okay, sounds great. So just the last questions from my side. I just saw that you also like support a lot of interesting integration like MLMD. Do you think anything else from the pedal community can be interesting in the Kubeflow perspective? Because Kubeflow is a project like we have also like AutoML, we have also like KF serving. Maybe any other parts of pedal can be integrated.
Yeah. So we've already integrated with the KF serving, but I think it will rename it to Kserve, right? So yeah, we've already integrated with the Kserve for the pedal inference part. So we cooperate with that. We cooperate with the KF serving on the predictor to implement the predictor and using the pedal inference. And then I think later on we are quite interested in some kind of fields like the auto ML, the Fed. I don't know whether we have federation.
Federated learning. I don't think right now we have it in Kubeflow.
Oh, okay. Yeah. So yep. So for some of the scenarios like the federation or the auto ML is always what we have interested. But we will cooperate with the community a lot on those side and see whether we can have some new project on those new field. I think we have already landed some project which we call the pedal FL on those like kind of for the Baidu app we already did some kind of federation stuff, but we need to figure out a place which can be integrated with the cloud native system. It used to be like just install the app on the phone, right? So you need to figure out whether they can be deployed or updated by using the Kubernetes.
Yeah, exactly. Because I think it's very interesting. Even if you speak about MLMD, this is like the high topic in Kubeflow overall in general cloud native world.
Yeah. Yes.
One last question. So most of the current training operators in Kubeflow don't support the elastic kind of training. So does it support like out of box, or do we need any extra support for that?
Yes, good question. So currently, Harvard supports the Elastic, but I don't think any other frameworks support those kind of stuff. They are really getting involved. Like they are tightly involved into the framework themselves. So with EDL, we just want to have a way for all kinds of frameworks to use, and it will be just like a plugin that you just need to change a small lines of code and then implement the like the fault tolerant and the like auto scales. So we are still investigating into it, and then maybe I can just give out another like speech later on in our next summit, and then discuss about those kind of technologies.
Yeah, that would be great, because I think that is one feature that is missing in most of the training operators. So that would be really great.
Yes.
Thank you.
Definitely. Any last questions to T regarding the pedal? Okay, sounds great. Thank you so much, Steve, for this presentation. It was really exciting, and I think we finally like integrate this part of the very interesting projects in Kubeflow.